Kitty DSA, the art of problem solving. In the next few minutes, let's travel through the foundations that power every great software system. Data structures and algorithms. What exactly are they? They are the building blocks of programming, a way to store data efficiently, a method to solve problems faster. DSA is the perfect mix of logic and optimization. Why does DSA matter? Because it shapes how an engineer thinks. It improves performance, reduces time and memory usage, and forms the core of coding interviews. From databases to operating systems to compilers, DSA is everywhere. Remember, fast code is simply smart structure paired with the right algorithm. Let's begin with data structures. Arrays, the simplest yet most powerful data container. A fixed-size sequence offering lightning-fast access, used in images, maps, and any structure that demands position-based lookup. Linked lists, a flexible chain of elements connected by pointers, perfect when size changes frequently. Inserting or deleting is quick and efficient. You'll find them inside memory allocators and playlist queues. Stacks, last in, first out. Pushing and popping elements just like plates stacked on each other. Used in undo operations, recursion, and program parsing. Queues, first in, first out. Real-life lines brought into computing, essential for OS scheduling, network packet management, and breadth-first search. HashMaps, key-value storage built for speed, with average operations in constant time, critical for caches, compilers, and the indexing behind large-scale databases. Trees, hierarchical structures that mirror real-world organization. Binary trees let each node branch into two children. From file systems to data indexing to AI search, trees form the backbone. Graphs, nodes connected by relationships. They model networks, maps, social media connections, and complex real-world systems. Algorithms like BFS, DFS, and Dijkstra help us navigate these web-like structures. Now, algorithms. Searching. Linear search walks through each element. Binary search cuts the data in half each time, giving a massive speed boost, but only in sorted data. Sorting. The art of arranging data. Bubble sort, simple but slow. Merge sort, stable, reliable, and O of n log n. Quick sort, incredibly fast in practice. Sorting unlocks better performance in many other algorithms. Recursion, a function that calls itself. It mirrors natural problem breakdown, used in tree traversal, backtracking, and dynamic programming. Think Fibonacci or the Tower of Hanoi. Dynamic programming, the master technique. Break a problem into smaller subproblems. Store results. Avoid repeating work. Used in knapsack, longest increasing subsequence, and coin change. Dynamic programming is simply recursion, empowered by memory. Now let's see how DSA powers the real world. Google Maps uses graph algorithms to find the best routes. Instagram relies on hashing and sorting to deliver your feed. Databases use trees, B-trees in particular, to store and retrieve data quickly. WhatsApp uses queues to manage message delivery across millions of devices. How does DSA improve your career? It sharpens your mind. It helps you crack interviews at top companies. It strengthens your ability to reason, optimize, and build scalable systems. And it opens doors to back-end engineering, system design, and artificial intelligence. Your journey begins now. Start small, practice daily, and shape your mind into that of an engineer. This is the first step into a world of endless problem solving.